Hey guys, this is Miss Regine from Soar Educational Services, and today I want to go over the AP Precalculus 2024 FRQ. So this particular problem says on the initial day of sale, T equals 0 for a new video game, there were 40,000 units of games sold that day. 91 days later, T equals 91, there were 76,000 of games sold that day. The number of units of video games sold on any given day can be modeled by the function g given by g of t equals a plus b natural log of t plus 1, where g of t is the number of units sold in thousands on day t since the initial day of sale. Use the given data to write two equations that can be used to find the value for the constant a and b in the expression. So for part one, we're going to write our equation, and I'll just do it to the left here. We have we'll start with day 0, 40,000 units were sold. So we're just going to write 40 for simplicity equals, all right, we have A plus B natural log of 0 plus 1. All right, and then the second equation is we had 76,000 units sold, and that is A plus B natural log of 91 plus 1. So that's part one. That's our equation. We get our points for that. So now part two says find the value of A and B as decimal approximation. So you would need a graphing calculator or use Desmos graphing calculator. The natural log of 1 is 0. So then you'll have B times 0, which is just 0. And so you'll just be left with A equals 40. So now we have already solved for the natural log. For A, sorry. We solved for A equals 40. So now that we know A equals 40, so this is very similar to a system of equation. You're going to plug 40 in for A. You're substituting 40 in for A. So here we have 40 plus B, and then natural log of 92. And we need to solve for B. So we're going to solve algebraically. So minus 40 minus 40. 76 minus 40 is 36 equals B natural log of 92. And then we're going to divide by 9, divide the natural log of 92. To solve for B, we're going to isolate B. So 36 divided by the natural log of 92. And that gave me 7.96. So now we solve for A and B. Now the next thing, it says use the given data to find the average rate of change of the number of units of video games sold in thousands per day from T equals 0 to T equals 91. So if you think about it, like whenever they're asking for average rate of change, you're just finding the slope. So we'll use y2 minus y1 over x2 minus x1. So what I was saying is if you think about it, you can write this as an ordered pair. On day 0, we have sold 40,000. And on day 91, we have sold 76. So now for Y2, I can have that 76 minus 40. So that's Y2 minus Y1, and then X2 is 91 minus 0. And that is 36 over 91. So our slope from day 0 to day 70 to day 91 is 36 over 91. Oh, it does say express it as a decimal approximation. So give me a minute. All right, so 36 divided by 91 is 0.395. We can round it to 0.396. It doesn't say how many decimal places. So 0.396. So that's decimal approximation. All right, so now the next part says use the average rate of change to find found in I1 to estimate the number of units of the video game sold in thousands on day t equals 50. Show the work that leads to your answer. All right, so let's erase this since we've already taken care of that. All right, so what we know is our initial value. We are at 40 for our initial value. On day 0, maybe people pre-ordered or whatever, but first day they've already sold 40,000. Then now we have an average rate of change of 0.396. And so if we assume like this was a linear relationship and this was sort of a constant rate of change, we would expect on day 50, because right now we went from day 0 to 91. So they want to know, well, what was day 50? What do we think we might have sold around day 50? That would be 59.8. Mm-hmm. So 59.8. So 59,800, that is. So you want to be accurate when you write it. So we would expect to sell 59,800 games on day 50. Now, part 3 of that says, let A of T represents the estimate number of units of video games sold in 1,000 using the average rate of change found in I. For A of 50 found in II, it can be shown as A of 50 is less than G of 50. Explain why in general. So here's what this part is asking us. So we assume that this was like a linear relationship, a constant rate of change of 0.396 per day, and that in that case we would have 59,800. Well, but that's not reality of this problem. They gave us the function for this problem, and it's a natural log. So it has a curve. It's not a constant rate of change. So if you actually use that natural log formula, we do know A is 40. We solve for B, which was about 7.96. And we're doing the natural log of 50 plus 1, which is 51. And that answer gave us about 71,297. So as we can see, using our average rate of change, assuming that it's a constant relationship, gives us a smaller answer. So A of 50, that's what that means, that A of 50, that average rate of change on day 50 is less than that function that was actually given when G of 50, the more accurate relationship. So it says explain why. Well, that's because this particular graph, if I just draw, let me see a rough estimate of it. It's a natural log graph. So natural log graphs have these curves. So we can expect it something like this. So, but in our particular scenario, okay, so at day 50, let's say this is day 50, according to our natural log graph, it would be right here, 71,000. But now, if you really look at that average rate of change, and I really don't have a lot of space, but day 91, let's say, maybe I need to move day 50. Let's try moving that a little bit just to give more space and show my point. Okay, so day 50, we're at 71,000 according to our function. Day 91, we're at 76. So this is the secant line that the average rate of change shows. And we use that secant line when we said A of 50, we use that secant line to see, oh, okay, it's at 59,000. So as you can see, that secant line is below our curve. So this is concave down. And this is something that the pre-calculus test really focuses on or emphasize. So when your average rate of change gives a value that is lower than the actual function, then that is a concave down graph. All right. Then the final section says, the makers of the video game reported that the daily sale of the video game decreased each day after t equals 91. Explain why there's an error in the model G increases after t equals 91. Well, according to the natural log function that we were given, there's going to be a constant rate of increase. So if in actuality, if the model actually decreases after t equals 91, then that function would not work for any day past t equals 91. All right, and that was all. I hope this was helpful. Remember to like and subscribe. Ask any questions or let me know any further videos that you would like me to make, and I'll see you next time. Bye.